Okay, in this video we're going to talk about city population problems. You're going to remember in previous problems we talked about with bank accounts, the amount that you have in your bank account is equal to PE to the RT. The amount of money that you have is equal to the principal that you put in, the starting amount of money, times E raised to the growth rate times the time. So we're going to use the same exact formula, except this time we are going to talk about, instead of number of dollar bills, we're going to talk about number of people. So here's what I know. The population of the city is 3.5 million in 1980, and it's 5 million in 1990. So I can consider then the starting population to be 3.5 million, and I can consider the final population 10 years later to be 5 million. You see, my first job is to solve for the growth rate. So I can find out the growth rate by saying that 3.5 million is going to be multiplied by e to the r, which I'm trying to solve for, and the t, the time, is the time in years, which is 10. So the steps that I take then, I need to divide both sides by 3.5 million. And what that does is that gets the e by itself. 5 million divided by 3.5 million is the same thing as 10 over 7. That's what it reduces to. So I'm going to leave it like that for now. I know I can put it in decimal form, but this will work. That's equal to e to the 10r, right? I just put the r and the 10 in a different order. R times 10 is 10 times r. Now that I have the e by itself, I need to get rid of the e, which means taking the natural log of both sides. So the natural log of 10 sevenths is the same thing as the natural log of e to the 10r. And the reason I do that is because the natural log and the e go away. That leaves me the 10r on the right. So if the natural log of 10 sevenths is equal to 10r, then to get r by itself, I just need to take this value and divide it by 10. All I have done here, I'm not solving for a time period, I'm not finding anything else. All I've done is I've found the growth rate. And this is going to be a small decimal because I'm talking about percentages. So natural log of 10 sevenths is this value. Divided by 10, it turns out it grows at a rate of about 3.5667%. Now the thing is whenever you're working problems like this, you do not want to round this answer. So I'm going to keep all these things, or even better, I'm going to store them on my calculator. So if you look next to the 1 button, you see STO. I'm going to store my answer, so I just clicked on that. I'm going to store that answer as alpha A. I'm going to store that letter as A. I'm going to hit enter. It is now stored as answer A. Okay, here we go. Now the real question. Find the month and the year that the population is going to be 6.5 million. So I need to do this a second time, but the nice thing is I now have the R value. When is the population going to be 6.5 million? Well, I'm basing this off of a starting population of 3.5 million. And that's going to be raised to e to the, and I'm going to go ahead and put, remember how we used a? I'm going to go ahead and put that. That's really that 0.035. And then I need to solve for t, right? So I now know what this a value is. Keep that in mind. But my first step to solving for t is I'm going to divide both sides by 3.5 million once again. And it turns out that 6.5 million over 3.5 million ends up being 13 sevenths. That's equal to e to the AT. Now that I've gotten the e by itself, I need to natural log both sides. So the natural log of 13 sevenths is going to leave me that AT value, because natural log and e go away. So to get the time by itself, then, I need to take the natural log of 13 sevenths, and I need to divide by that a value. T is going to be equal to natural log of 13 sevenths divided by my stored a value. So here we go. Natural log of 13 sevenths is this. I divide it by the 0.035, which is dividing it by the a value that I've stored in my calculator. It turns out it's 17.3558 years. $17.3558 years since when? Well, the beginning of our time period was 1980, so we're talking 17 years later. We're talking 1997. Now, the tougher part, we need to find the month, right? What month is that? So in order to find the month, here's what I need to know. let's see, 17 years later, I'm going to subtract the 17 just so I'm left with the decimal. I'm 0.3558 ways, or that decimal the way through the next year, right? Well, what is that out of 12? If I multiply by 12, it tells me that's the 4th month, about a quarter of the way through the 4th month even. But it turns out then the 4th month is April. April of 1997 is when it's going to hit 6.5 million people for a population. So once again, before I turn this video off, 2 steps to doing these population problems. Step 1, solve for the growth rate. Step 2, and if you need to, solve, right, take that and store it in your calculator. I'm going to call that A. But then once we have the growth rate, then we use that growth rate to solve, usually for a time period.